Assalamualaikum, my name is Nadira binti Zanwa from RAS1154B. Today I would like to discuss about the detection of toxic metal level in cocoa powder and chocolate food. Chocolate is very popular among the general population due to its taste being so good and addictive. In addition, chocolate is also good for our brain health. The Swinburne University of Technology Centre for Human Pharmacology in Melbourne, Australia, conducted a study in which it was discovered that certain components of chocolate improve mood while others altered brain patterns. These components are most likely tryptophan, an amino acid found in chocolate that aids the brain in the production of serotonin, and neurotransmitter that makes us feel happy and satisfied. Despite all of its benefits, chocolate does have some drawbacks. Almost every cocoa powder has been tested by consumer lab, including Nestle, Trader Joe's, and Hershey's, and clearly contain dangerous high level of cadmium, arsenic, and lead. In general, cadmium is a metal found in soil that can occasionally be found in plants such as rice and cocoa. Cooperman explained that nearly everyone is exposed to small amounts of cadmium in their diet. However, too much cadmium can cause their health problems mentioned above. According to research, it is also a possible cancer cause. The objective of this case study are to learn how to prepare cocoa powder using microwave-assisted digestion, which are to dissolve heavy metal in the small presence of organic molecules and to analyze the molecules such as plasma, atomic absorption, or atomic emission measurements. The second objective is to determine types of toxic metal and level that can be found in cocoa powder using ICP-MS method. There are so many unwanted toxic metals in cocoa powders that can be analyzed by using this ICP-MS method. This method provides us the best results so that we can prevent the high toxic metals in chocolates for consumer. For sample preparation and method use, we use cocoa powder and chocolate products as a sample in this case study. In this section, we will go through how samples are prepared before being run through the ICP-MS. Firstly, 155 samples of cocoa powder and chocolate manufactured in Italy were collected from local supermarkets throughout this country in 2015. All the samples represent 5 popular brands available in the market and were categorized into 4 different types, according to the Commission regulation. Regulation datasheet represents the amount of maximum level of cadmium in foodstuff, so that we have 35 samples of chocolate with less than 30% total dry cocoa solids, 35 samples of chocolate with 30% to 50% total dry chocolate solids, and 35 samples of chocolate with greater than 50% total dry cocoa solids. All the samples were transferred and stored at 4 Celsius and above before being processed for analysis. It must be analyzed before the expired date occurs. Before that, a sample of chocolate with dry cocoa solids content less than 30% was chosen for the ICP-MS validation. Then the sample start to digestion according to the UNIEN standard. For this case, the samples was digested using microwave-assisted digestion. 1 gram of samples were weighed and put into previously decontaminated containers containing 3 ml of 60% volume over volume ultra pure nitric acid and 5 ml diionized water. The microwave digestion for 10 vessels followed a power rise about to 600 watt in 10 minutes. The same power was maintained for 40 minutes to have an accurate result. Lastly, the vessels were cooled for 15 minutes. This below show the following instrumental condition instrument use. RSD values of less than 3% were accepted for resolution. The concentration was determined by adding the isotopes. The signal intensity was attenuated by the metric effect, and metric effect was corrected online by 11 determining the internal standard associated with all elements. In order to reduce interference, the analysis were carried out using helium and hydrogen gas in a dynamic reaction cell when the level of interfering elements produced.
Assalamualaikum and hi, my name is Umi Humairah binti Abdul Rahman. I will continue with this presentation with the result and discussion part. In these sections, we use the ICP-MS instrument because it provides rapid multi-elemental analysis of food matrix, exceptional sensitivity, and selectivity in a short amount of time. This instrument only needs 2 minutes to test of each sample with the method validated, and it also able to rate concentration of metals below 0.001 mg per kilogram. 4 table below show the result of the concentration of selected toxic metal in cocoa powder and chocolate with unit milligram per kilogram. Next, we will discuss in detail about the result. Firstly, we can see in table A, the maximum toxic metals concentration range for cocoa powder sample were observed to be 0.303 plus minus 0.035 mg per kilogram of cadmium, 1.228 plus minus 0.146 mg per kilogram for leads, and 0.094 plus minus 0.013 mg per kilogram of arsenic. Furthermore, cadmium concentrations obtained were below the permissible level established by the International Cocoa Organization, which is 0.6 mg per kilogram, and by Commission regulations. Other than that, we can identify that chocolate sample with less than 30% dry cocoa content had the lowest metal value from other with the maximum concentration is 0.545 plus minus 0.070 of leads, 0.050 plus minus 0.00C of cadmium, and also 0.013 plus minus 0.02 of arsenic metal. So, from that, we can assume that use a little amount of sample in the formulation will decrease of toxic metal level in cocoa powder or chocolates. However, with a dry cocoa content below 30%, we are unable to obtain the data because it did not follow a long normal distribution. Therefore, we will carry out a cross-scale valid test. We have to determine if there are statistically significant difference between multiple groups. So, the result obtained with significant difference be less than 0.5 between cocoa powder and chocolate sample for all of the toxic metals studied. Therefore, we can know the toxic metals concentration found in cocoa powder and chocolate with dry cocoa content more than 50% were significantly higher than the other chocolate sample with using Nimini test.
Assalamualaikum and hi everyone. My name is Intan Amalia binti Azman from group RAS1154B, and today I'm going to discuss about toxic metal distributions in cocoa plants. Generally, toxic metal distributions in cocoa plants was decreased from beans to leaf. Cadmium was discovered in shells when the concentrations in beans was greater than 1 mg per kilogram. Shavers et al. 2015. The results of this study showed cadmium and plumbum levels in dark chocolates and milk samples from Malaysia were significantly lower than those observed by Lee et al. 1985, Miller et al. 2011 of 0.83, 0.41 and 1.94 mg per kilogram. So it is accordance with the standards Malaysia legislations for cocoa powder. The levels of plumbum discovered in chocolate samples with a dry cocoa content of more than 50% and between 30 and 50% were significantly higher than those reported in chocolate samples studied by Yanes et al. 2014, 0.088 and 0.083 mg per kilogram. Han in 2012 found similar amounts of cadmium and plumbum in chocolate samples to those found in our studies. Cadmium 0.046 and plumbum 0.36 mg per kilogram, greater than 50% cocoa powder. following the food sector that has adapted to European rules. Arsenic is used in some medicines form. Despite significant safety issue, arsenic is frequently utilized in extremely diluted homeopathic medicines for digestive disorders, food poisoning, insomnia, allergies, anxiety, depressions, and obsessive-compulsive disorders, OCD. Arsenic is a trace element found in very many concentrations in the human diet. Its precise role remains unknown. A typical adult diet contains 12 to 50 micrograms of arsenic per day. A daily intake of 12 to 25 micrograms has been proposed. Arsenic trioxide causes cancer cells to die faster in leukemia if consumed in excess. Only as far as we know, serve no fundamental purpose in the human body. It can only cause harm when ingested through food, air, or water. Cadmium is not known to have any beneficial effects on the human body, which is a toxin that accumulates over time. Cadmium is carried in the blood by methelatinin. The kidneys and livers have the highest cadmium concentrations. Cadmium has the potential to harm the general population's kidneys and bones.
I will continue the presentation with the advantages and limitation of this method. So ICP-MS method has the ability to examine almost all elements in the periodic table at low concentration while maintaining its high dynamic range. By using low sample volume, frequently with relatively simple preparation processes are usually enough to get the desired results. This method also can distinguish between stable and radioactive isotope that allows high precision isotope ratio measurements. As previously said, ICP-MS method is the best detector selective for hyperhinated procedures that require some sort of separation process to determine any metal exists beyond surrounding. However, there are limitations of this method where it includes the high cost of the equipment which requires a high level of staff proficiency. The knowledge and the skills of the method are hard to find in people as this method are used in specialized areas that require a lot of guidance. Mass interference also have been a common issue as it have been less effective when it comes to eliminate isobaric mass interference. Furthermore, we identified that the method that we use, which is microwave digestion, has been proven to be a highly valuable sample preparation method in trace metal analysis. It helps in the digestion process that has been mixed with concentrated acid, breaking down solids into solution and allowing them to be analyzed for the result. In this industry, we can see that many companies use this microwave-assisted digestion because it can save time and energy. This is because it is possible to heat 8 until 12 samples at the same time and reaction times are typically less than an hour compared to open acid digestion, which consumes 5 until 12 hours to digest the sample. Another advantage of using microwave-assisted digestion is that this instrument only requires lower acid in order to run the samples, and there is no exposure of the analysis to corrosive acid fumes. In addition, microwave-assisted digestion has only one limitation, which is the explosion and cracking of digestion tubes due to the simultaneous pressure and temperature increases. However, microwave systems have inbuilt sensors for both temperature and pressure to overcome this problem. When the pressure approaches the maximum limit, the microwave power is automatically adjusted or cut off. We can say that microwave-assisted digestion is a very efficient and useful addition to high-throughput laboratories. As a conclusion, detection of toxic metal is highly important as it affects our life if it exceeds the percent required to avoid any complication of health. Toxic metal will remain exist in all sorts of food when its species come from nature. Obviously, all the food needed to be analyzed and tested using suitable method and instrument to detect any foreign metal in order to ensure that it is safe to produce for the market and safe to consume. So there are numerous techniques or methods have been used for detection of metal, which can be divided into 3 main categories, which is spectroscopic detection techniques, electrochemical detection technique, and optical detection techniques. So all of the technique mentioned has its function to detect the metal and variety of food. By doing the analysis, health complications can be avoided and the product is totally safe to consume. That's all from us. Thank you.